Hey guys, we are back here with the continuation of the same topic elements, compounds, and mixture. We have invested so many short videos on this, and in the last video, we have just discussed about a mixture and how we can differentiate between mixture and a compound. That compound has a fixed ratio of its components, mixture does not have a fixed ratio of its components, and components of the compound are not maintaining their properties, whereas mixture components are maintaining their properties. And the last point was that in case of a compound we cannot separate the components without electrolysis, whereas the components of the mixture can be separated from each other with the help of physical techniques which we have studied already. And those physical techniques are including filtration, centrifugation, followed by filtration, sublimation, etc. etc. Okay. Now I am taking you to the next topic, and the next topic is related to the general structure of a metal. General structure of a metal. Okay, so what is the meaning of this topic first of all? It is the structure of a metal. For example, examiner is asking you to draw the structure of zinc metal. You will draw this structure. Examiner is asking you draw the structure of gold. You will draw this. Examiner is asking you draw the structure of sodium. You will draw this. So this is the structure of all the metals of the periodic table. Okay, what is that structure? So first of all, you are going to make a small box, not very small, not very huge. Okay. And in this box, you are going to make the positively charged nuclei. Here, I am making these type of nuclei here. Okay. There should be in the circular form, and there should be a regularity here. A uniform arrangement should be there. You can see this thing. Okay. These are now positively charged. To differentiate the positive charge very clearly, I have changed the color, and this is positively charged. These are positively charged nuclei along with the negatively charged electronic C. You can see this negatively charged electrons are spreading here and there. They are so huge in number, we cannot count this. These are the electrons from the outermost shell from every atom. Okay, so now sometimes we can draw it with the E symbol and the negative sign on it. Okay, we can draw it with that as well. Now I'm going to label this. So what is this? This is the positively charged positively charged nuclei. All right. And what about the other thing? This is called negatively charged electronic C. Okay, electronic C. Now we are moving ahead towards its detail. We can say this thing that in case of all the metals, positively charged nuclei are immersed in the negatively charged electronic sea. Immersed is with IMM. It means they are inside that negatively charged electronic sea. Now the point is this, from where these electrons are coming. These electrons are from the outermost shell of every atom. Okay, outermost shell only. I am mentioning this point again and again. Then next point is this, that there are certain properties associated with this structure of a metal. What are those properties? Number one property is that a metal can be converted into sheet, or we can say that can be converted into sheets and layers, we can say. Okay, now what is this? We have seen aluminum foil in our homes and how it is made. There is one property which is called as malleability. What is malleability? A metal can be hammered. For example, a block of metal can be hammered into layers. Whenever we are going to hammer that block of metal, it will be converted into sheets. Okay, why it can be converted into sheets? The reason is this, that in case of a pure metal, the layers can slip over each other, the layers can slide over each other. Due to this reason, the metal layers can slide and slip. They are convertible into sheets, and that property is called as malleability. Okay, that property is called as malleability. Okay, there is another property. We can say that metals are ductile. What is the meaning of being ductile? A metal can be converted into wires. A metal can be converted into wire. The very common example of metal conversion into wire is the copper wire. We know now very clearly that a copper wire can conduct electricity. It is used in our homes and everywhere to conduct electricity, to conduct electric current. And this ductility is the property due to which a metal is conducting electricity. Okay, so now we can say about this that a metal can be converted into layers and sheets due to its malleability, whereas in case of conversion into wires, we can say this thing that metal can be converted into wires due to ductility. So there are two types of the properties. One is ductility, whereas the other is malleability. Layers can slide over each other. Which layers can slide over each other? Positively charged nuclei can slide over each other, due to which a metal can be converted into sheets, whereas how it is convertible into wires due to ductility. Is that okay right now? So this is just the properties which are associated with this structure. There is one other property. A metal can conduct electricity in the solid state and in the molten state as well. Why a metal can conduct electricity? Due to availability of mobile electrons. The term is, I'm writing this term here, due to ability of mobile, due to the presence of mobile electrons. As the electrons are mobile, what is the meaning of mobile electrons? That the electrons can move from one place to another place. So basically, whenever the electric current is passing through a metal, what is happening? Basically, old electrons are replaced by new electrons. Positively charged nuclei stay in position, just the old electrons are replaced by new electrons. That's why conduction of electric current is possible. So now, before moving ahead, I would like to inform you what is current. Current is flow of electrons. So whenever the current is passing through a metal, old electrons are replaced by new electrons. Positively charged nuclei stay in position, and in this way, we can say this thing that electric current is passing through a metal. Okay, so this is the generalized structure of a metal. Positively charged nuclei are immersed in the negatively charged electronic sea. Positively charged nuclei can slip over each other, can slide over each other. Due to this property, a metal can be converted into sheets, into layers. And one of the example is aluminum foil. There is another thing that metals are ductile. They can be converted into wires. And there is another property of a metal, that every metal can be converted into electricity conducting substance. I mean to say, it can conduct electricity due to availability of mobile electrons. Okay, now I'm changing the page and I'm taking you to the new concept, and that new concept is related to alloy. Okay, so what is alloy? An alloy is basically a combination of a metal with an other metal or a non-metal. So in case of an alloy, a metal can be mixed up with another metal or with non-metals as well. So one metal is melted and other metal is melted by heating, and their molten forms are mixed up with each other in a specific ratio, and that mixture is called as alloy. Okay, so basically in alloy formation, no chemical reaction is happening. So be careful about that. That alloy does not have any formula, because alloy is not a compound. Alloy is a mixture in which a specific ratio of the components can be mixed up with each other to achieve the specific abilities, to achieve the specific properties. Now, what is an alloy, first of all? Okay, so just look into this diagram. Whenever examiner is asking you to draw the diagram of any alloy, you are going to draw this structure. What is the structure? First of all, I am trying to change the color. So for example, this is one big ball, there is another one big ball, and there is one more. Okay, now I am trying to take one with the other color. Okay, you can see this thing, that in case of an alloy, two different sizes we can observe. One bigger sizes, whereas the other are smaller sizes. Particles are just fixed up with each other. We can see in this case there is no sliding possible, as the particles are fixed with each other, and no spaces are there, due to which the particles are holding each other more tightly. We can observe this. Okay, now what is the labeling of this diagram? Is labeling very important? Yes, labeling is very important. Examiner is asking very clearly draw the label diagram of zinc metal, draw the label diagram of iron metal. So if you are not going to write down the labeling, the marks will obviously not be there. Okay, so what is this and what is this? Okay, so this is metal A, whereas the other is metal B. Okay, metal B is there. Okay, now we are going to discuss it further. Guys, alloy is much preferred over a pure metal. Why it is so? This is very important. Point number one is this, that in case of an alloy, it is stronger and harder as compared to a pure metal. Why it is so? Because in case of a pure metal, the particles, positively charged nuclei, can slide over each other, can slip over each other, due to which a pure metal is softer as compared to an alloy. Whereas in case of an alloy, due to different sizes, the particles are prohibiting the slip and slide over each other. They are entangled with each other. They cannot slip and slide over each other. Due to this reason, an alloy is harder and stronger as compared to a pure metal. Okay, this is point number one. There is number 2 point, and that is that a low melting point is associated with that of an alloy. And why it is so? We have studied this thing when we were studying, when I have taught you about the melting point as a purity checking technique. Okay, in that case, we have discussed this thing, that whenever any impurity is added to a solid substance, this impurity is breaking down the forces of attraction among the particles of a solid. As a result of that, the melting point of a solid is decreased. The process was called as depression in the melting point. Here, in case of an alloy, when impurities are added, I mean to say another element, a metal or a non-metal, is behaving like an impurity, and it will obviously now it will obviously now not let that metal as a pure substance. It is now added as an impurity. So now this impurity will break up the forces of attractions which were present in case of a pure metal. Okay, now what is going to happen here, that due to this impurity, the melting point will be decreased. Okay, so pure metal has a high melting point, whereas impure metal has a low melting point. Okay, so I mean to say an alloy has a low melting point. Okay, I am going to mention a few melting points here as well. For example, I am just telling you that melting point of pure iron is, let's suppose, 1550 degrees Celsius. Okay, so this is just the melting point of iron. Okay, so if I'm talking about the melting point of stainless steel, let's suppose, okay, so its melting point can be a range. Okay, so its melting point will be decreased, for example, to 1400. Okay, so let's suppose like this, the melting point can be reduced in that case. Okay, so I'm just telling you that melting point is decreased in case of an alloy, and it is lesser than that of a pure metal. Okay, so number 3 point is this, that decorative point of view is this, there is present here as well. In case of a pure metal, for example, if copper is added, copper is of pink color. I will discuss the colors of the metals with you as well, and the colors required regarding your paper. But right now I'm telling you, for example, iron is of dark gray blacky color. Okay, if copper will be added to it, it will give a pink tone, a pink color, a pink shade to that metal. Okay, so in that case, we can say a decorative point of view can be achieved as well. Appearance can be improved. So these are the 3 points. Can we write this decorative thingy or the appearance thingy in the exam? Yes, it is important regarding paper. That's why we can write it. Okay, so this is an alloy, how it is made, and what are the properties associated with that, I have discussed with you. But there are certain other things associated with alloy which I'm going to tell you right now. Okay, an alloy can conduct electricity. Okay, alloy can conduct electricity. Why? due to availability of sea of electrons, or you may say due to mobile electrons. Mobile electrons is the actual term which is required by the examiner. Due to mobile electrons. Why mobile electrons are required? Sea of electrons means that electrons are present there. Mobile electrons means that electrons are not only present there, rather they are moving, they are movable, they can move from one place to another place. Okay, so this is how examiner is asking. We have to write this thing that a metal can conduct electricity due to mobile electrons, and an alloy can conduct electricity due to mobile electrons, very, very clearly. Okay, now there is one more point which you should know, that in case of an alloy, I have given you the properties associated with the alloy. I have discussed with you that why an alloy can conduct electricity, and there is one more point which you should know is this, that in case of in case of an alloy, basically there are different examples of alloy which you should know. Number one example which I am telling you right now is a stainless steel. Stainless steel. And what is stainless steel made up of? Stainless steel is made up of iron. Stainless steel is including chromium, it is including nickel and carbon. Chromium symbol Cr, nickel symbol Ni, and iron symbol Fe, and carbon is carbon C. Okay, so these are the elements which are just mixed up with each other to give you stainless steel. There is another example, and that is called as brass. And brass is made up of copper and zinc. Okay, so brass, and there are other examples for the alloy as well. Do we need to know that brass is made up of copper and zinc? Yes, you need to know. Do we need to know about stainless steel composition? Yes. Do we need to know about the composition of many alloys? No. So you can have any idea that in addition to brass, bronze is there as well. This is also an example of an alloy. Okay, so there are certain examples of alloy which I have discussed with you, and the composition, etc. Thank you very much, guys. Take care of yourselves. See you in the next class.